So now using the Maxwell-Boltzmann distribution law, we'll find the average speed, most probable speed, and root mean square speed of a gaseous system. Okay, so we'll first start with the average speed. See, the term we are using is average speed, okay, not velocity. Why is that? Because you see, in a gaseous system, the gas molecules can move with all possible velocities between 0 to infinity in all possible direction. So if you take a gaseous system, you will find that the gas molecules can have any velocity between 0 to infinity, and they can move in all possible directions. So if we try to find average velocity, then what will happen? Now velocity is a vector quantity. So we have to consider, when we are calculating the average velocity, we have to consider the magnitude of the gas, the velocity, magnitude of the velocity of the gas molecules, as well as their direction. So what will happen? So we have to consider their magnitude, magnitude of the velocity, as well as the direction, in the direction in which the gas molecules are moving. So what will happen in average? In average it will be 0. That is, you can find some gas molecules which are moving with some velocity in a direction, particular direction. You will find that there will be another gas molecule with the same velocity moving in the opposite direction. So it will be, suppose in one molecule is moving with 5 centimeter per second, 5 meter per second in this direction, you will find that another molecule is moving with same velocity 5 meter per second but in opposite direction. So in average it will be plus 5 minus 5 and it will be 0. Okay, so in a gaseous system you can find that you will find a pair of molecules which will have same velocity, but they are moving in same magnitude, but they are moving in different opposite directions. So in average it will be 0. Okay, so that's why what we will do, instead of calculating average velocity, we will calculate average speed, because as speed is a scalar quantity, we will consider only the magnitude, not the direction. So while taking the average, the result will not be 0, because you are considering only the magnitude, not the direction. Okay, so how do you calculate the average speed? Suppose there are N1 molecules which are moving with speed C1. Okay, then there are N2 molecules moving with speed C2. Okay, then N3 molecules moving with speed C3, etc. Then suppose Ni molecules moving with speed Ci. Okay, so now we'll find the average speed. As you can see, different number of molecules are moving with different speed. We can find their average speed. So how do we find that? So suppose, first consider one example. Suppose there is one type of pen. Okay, so the first type of pen, each of them cost rupees, suppose 10. There is another type of pen. Okay, and each of them cost rupees, suppose 5. Okay, and you want to buy two of the first type of pen and 3 second type of pens. Okay, so what will be the average cost? Okay, so if you buy two first type of pens and 3 second type of pens, then what will be the average cost? So what will be the average cost? It will be total cost divided by the total number of pens. Okay, so what is the total cost? It will be the cost due to the first type of pen, which is you are buying 2 of them. Each of them cost rupees 10. So 2 of them will cost 2 into 10 plus. Now we are buying 3 of the second type of pens. Okay, so and each of them cost rupees 5. So 3 of them will cost 3 into 5 divided by total number of pen is 2 plus 3. 2 plus 3. So the total cost will be 20 plus 15 divided by 5, which is 7. Okay, so the average cost is 7. Okay, so similarly, you see here there are N1 molecules moving with speed C1, N2 molecules moving with, suppose if I write N2 over here, N2 molecules moving with speed C2, N3 molecules moving with speed C3. Then following the same method we used over here, if we find the average speed, so what will be the average speed? So in this case also you see, so you can say that suppose there are the first type of N1 pens each cost rupees C1 and N2 number of second type of pens each cost rupees C2. Okay, so what will be the average cost? It will be N1 C1 plus N2 C2 divided by total number of pens, which is N1 plus N2. That will be your average cost. Okay, so first type of N1 number of pens each cost rupees C1 and second type of N2 number of pens each cost rupees C2. So total cost is N1 C1 plus N2 C2 divided by total number of pens N1 plus N2. Okay, so this will give the average cost. So similarly, what will be the average speed? Now we have N1 number of molecules moving with speed C1, N2 number of molecules moving with speed C2 and so on. Therefore, what will be the average speed? It can be written as C bar. C bar denotes, this is bar sign, this denotes the average speed. It will be N1 C1 plus N2 C2 plus N3 C3 plus dot 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 Ni Ci and so on. Okay, then again divided by the total number of molecules, which will be N1 plus N2 plus N3 plus Ni plus dot dot dot. Okay, and so on. Okay, so we can write it as summation over I Ni Ci divided by summation over I Ni. Now summation over Ni is nothing but the total number of molecules, gas molecules in the gaseous system, which we consider to be capital N. Okay, and it will remain as it is, Ni Ci. Okay, now this summation is valid when the speeds the value of speed are discrete. But in our case, we know the gas molecules can move with any speed between 0 to infinity. Okay, so and also if you look at the distribution curve that we discussed earlier, you see, okay, so the gas molecules can have any velocity between 0 to infinity. So the distribution of speed is continuous. Okay, so distribution of speed is continuous, which is not discrete. Okay, there is no some distinct and separate values of speed with which the gas molecules move. They can move with any value, any speed between 0 to infinity. That's why the distribution of speed is continuous. That's why what we cannot use this summation to find the average speed of the gas molecules in a system. So what we have to do, we replace the summation by integration. Okay, so what we say that suppose there are DNC number of molecules which are moving with speed c. Generally we say that they are moving with speed lying in the range c and c plus dc. Let's say that they are moving with speed c. Okay, so in that case the average speed, as we replace the summation by the integration, it will be, so it was NiCi, so Ni will be replaced by, Ni was the number of molecules here, Ni will be replaced by the number of molecule DNC, and Ci will be replaced by C divided by N, which is, so arranging we can write C DNC divided by N. Okay, so this will be the average speed where Ni is replaced by DNC and Ci is replaced by C. Okay, now we already know the value of DNC. If we put it in this integration, we can find what will be the average speed.